A polynomial equation is anything of the following form written down here. And so below this definition, I gave us a couple of examples. So y equals 3x squared plus x minus 5 is an example of a polynomial. Essentially, you're taking powers of x's and you're multiplying them numbers, and then you're adding it all together. So as a second example, we have y equals 2x cubed minus 5x squared minus 4x plus 2. So it's like one further than a quadratic. We just increased the exponent by 1, going up to an x cubed. I multiplied it by a 2. If you continue this process forever, we would call these equations polynomials. And I also included their graphs below here. A couple of terms with polynomials that I want to write down are something called the degree and the leading coefficient. The degree refers to the biggest exponent that appears within your equation when your equation is completely expanded out. If we look at y equals 3x squared plus x minus 5, I see there's this x squared, and we call the degree 2. On our second equation, the biggest exponent is this 3, so the degree of this one is 3. The degree tells you something about the graph. It tells you what the ends of the graph are doing. So for example, if you have an even degree, like 2, I know that the graph goes up on both sides. I also know that the graph goes up on both sides because of something called the leading coefficient. That is the number in front of the variable x. It's a positive 3. So I'll write that down here, that the leading coefficient is 3. Because this thing is positive and it's of even degree, I know the graph is opening upward on both sides. Now, if you compare that to this graph, here the degree is odd, and the leading coefficient is 2. That means the graph opens in opposite directions. It goes up on one side and down on the other. So that information is coming from this very first term of the polynomials. If you have something that's even degree with a positive coefficient, it's going to go up on both sides. If you have something that is of odd degree, also with a positive coefficient, one side's going up and one side's going down. If there were a negative leading coefficient, it would just flip the graph upside down. So the point here is that if you know just a couple of things about your equation, you'll know a little bit about the graph. But I wanted to focus on how we could actually factor these equations. So that's what I want to do here in example 1. I'd like to somehow factor the polynomial 2x cubed minus 15x squared minus 11x plus 24. A couple of things to point out are, well, the degree is 3, and it has a positive leading coefficient. And if you check out the graph, one side goes up, the other side goes down. So yeah, this definitely looks like an equation that has odd degree. The second thing is, I want to divide x minus 1 into this expression to try to break this up into a couple of pieces. If I look at the graph, I'm noticing that, okay, right here at x is equal to 1, the graph is equal to 0. So this is in fact a 0 of my equation. The second that you know a 0, for polynomials, you automatically know a factor, and that factor has to be x minus 1. What this means is, if I can somehow divide x minus 1 into this expression, it should go in evenly. The process by which we do this is called polynomial division. So what this looks like is, how many times can we divide x minus 1 into the expression 2x cubed minus 15x squared minus 11x plus 24. So the algorithm for it, it's really no different than if you were to say I'm dividing, 5 into 112. It really works the same way, you just have to use some rules of exponents. So I actually want to do this one out first, and then compare it to what it would look like to divide this out. And we'll probably need a little bit more space for this, so I'll put this on its own page. But for here, all right, if I divide 5 into 112, we start with this 1 and say, okay, well, 5 can't go into just 1, but it can go into 11, and you want to get as close to it as possible. So you'd put a 2 here. 2 times 5 is 10. So I placed a 2, multiplied it to my 5, I got to 10, and then whatever I put here, I have to subtract it away. The difference is 12, and then we just keep going. We ask, okay, well, how many times does 5 go into 12? Again, it's 2 times. That's the closest you can get because 5 times 2 is 10. We then subtract what we put here, and we reach this 2, which we call the remainder. So because this remainder is not 0, okay, well, 5 actually does not factor 112. But if you had a remainder of 0, it would mean that it would. So what I'm going to do is do this process, but on this expression here. And the ideas for it are very similar. Okay, so I rewrote the problem again, but what I'm trying to do here is divide x minus 1 into the original polynomial. The goal is to try to cancel this 2x cubed, so starting here. What do I multiply x minus 1 by to get as close to a 2x cubed as possible? Well, if I multiply this by 2, it'll match up with the 2. But if I want an x cubed, I have to multiply x by x squared. So this is the first portion of the question. I'm going to multiply this whole thing by 2x squared because it's going to give me a 2x cubed. I'm going to put all of the x squareds above this spot. So I'll make my choice of 2x squared. I then multiply 2x squared to this whole thing, and I write the answer directly below my first two terms. So I have 2x squared times x. That gives me 2x cubed. I then have 2x squared times this negative 1. So I get minus 2x squared. And the next step is, okay, the thing that I just put down here, I'm subtracting it away. And this is really important. I'm subtracting this whole thing from the two terms above it. So let's see, I get 2x cubed minus 2x cubed. Perfect. That's 0. You don't even have to write this, but the difference of those two things is 0. The second thing I get is, okay, negative 15x squared. I have a minus, so it's going to be plus. That's negative 15x squared plus 2x squared. That is negative 13x squared. I bring down my next term, and I repeat this process. The question is, okay, I now want to cancel a negative 13x squared. What do I multiply x minus 1 by to get a negative 13x squared? Well, if I multiply by negative 13, okay, that's going to give me my constant. If I want an x squared, I'm going to multiply this by just an x. So this is the next piece, negative 13x. This negative 13x multiplies to this x, giving me a negative 13x squared. I then multiply negative 13x to this negative 1, and I get a positive 13x. I then subtract that thing away. I take that away. So I have negative 13 plus 13 for my x squared. So, okay, that's great. That gives me, again, 0. I wanted that to happen. But for the next piece, I have negative 11, and I'm going to have, okay, a minus 13x. So that's going to be 24. That is a negative 24x. The only thing I can do now is bring down that plus 24 at the very end, and I'm at my last step in the process. I want to think of something that goes here, so I cancel a negative 24x. All right. So for this, I think negative 24 is going to work perfectly. I get negative 24 times x, so that is negative 24x. I then get negative 24 times negative 1, which is a positive 24. And if I subtract these two things together, it should be that the remainder is 0. Let's see what happens. We get negative 24x plus 24x. Okay, that's perfect. That's 0. I then have 24 minus 24. So at the very end, I get 0, and this is my remainder. What all this means is, if you divide x minus 1 into the original polynomial, what is left is 2x squared minus 13x minus 24. So it's quite a lengthy process, but we use the same principle as the division algorithm for real numbers. So by dividing this into this, I was left with 2x squared minus 13x minus 24. Going backwards, that's saying if I then multiply those two things together, it would take me back to my original expression. And that is it for this example.